In general, we can't compute the Laplace of a product of functions f of t times g of t for any functions f and g. We are, however, able to compute the Laplace transform of products of certain functions. Here, we will look at the product where one function is e to the ct. That is, we'll compute the Laplace transform, Laplace of e to the ct times some generic function f of t. To do this, we'll come back to our definition of the Laplace transform, that the Laplace of f of t is the integral from 0 to infinity of e to the negative st times f of t dt is some function f of s. Applying that to our function here, we have the integral from 0 to infinity of e to the negative st times e to the ct times f of t dt. Now, one reason that we can compute the Laplace transform of a product of functions where one is an exponential is that we can combine e to the negative st times e to the ct as e to the negative st plus ct. And with this, we'll factor out negative t in the exponent to get e to the negative st plus ct is e to the negative s minus c times t, and rewrite our integral as the integral from 0 to infinity of e to the negative s minus c times t times f of t dt. Notice here that we are almost left with the definition of the Laplace transform. The only difference is that we have s minus c rather than just s. So our integral on the right is the function f evaluated not at s, but at s minus c. So we can conclude that the Laplace transform of e to the ct times f of t is f of s minus c, where the function f of s is the Laplace transform of f of t.